you. At this time, if you would like to ask a question, please press *1 on your touch-tone phone. You will be prompted to record your name. Please unmute your line and do so when prompted. To withdraw your request, you may press *2. Again, to ask your question, please press *1 and record your name at this time. One moment, please. Once again, please press *1 and record your name at this time. One moment, please, for the first question. David, you may ask your question.
Yes, my question is, if I want to do two zones in a house, can I treat them as two different simulation models by doing one HVAC system on the first floor and a second on the second floor?
At this time, BOP does only a single condition zone model. There are separate zones for unconditioned buffer zones, attics, garages, unfinished basements, etc. But there's only one HVAC system per home. Eric, you want to explain basements?
Sure.
This is Eric Wilson, also a colleague at NREL.
The one case where BOP does model a separate zone is for finished basements, but we still just model a single HVAC system. And I guess we would recommend against doing two separate simulations, one for each zone, because our assumptions about appliances and occupants would mean that we're assuming, each zone has its own refrigerator, oven, etc. Which you probably don't want. So we would probably recommend just modeling it as a single zone.
Understand. I have a second question, and that is, how do I do a flat roof simulation?
So go back to BOP. There is a flat roof option on the drawing tool. So I have what currently is a one-story building with a attic, and so flat roof deck. So if I select this option, and I'll double-click here, then I have my kind of innocuous-looking flat roof.
Can we make that tilted so that if we have a 40-foot long building with a 2-degree slope, that it'll show the direction?
BOP does not currently do that type of roof or a shed roof. If it's, what did you say, a 2-degree pitch?
Well, just pulling out a number, I think of all of the retrofit Baltimore, Philadelphia, metropolitan row houses that all pitch to one end direction, and they're all row buildings. I also think of out here in the Southwest, all of our Adobe-style, Santa Fe-style houses with single pitch roof off the back with a parapet wall around it. And where in the front of the building it might have a quote-unquote roof cavity of 3 feet, and in the back it might have 6 inches, depending on the slope and the depth of the building.
I see. So, again, one thing to keep in mind for this question and others with regard to geometry is while it's nice and to have a rendering of the building, and it's good to kind of verify that what you've input in drawing is giving you a building similar to your intentions or equal to your intentions. The drawing tool is not completely flexible. So the question is, how much difference does it actually make, not just in the appearance of the rendering, but in the energy performance of the building? And you indicated an aspect where that might make a difference if you're putting in insulation that is exceeding the available space. Under those circumstances, because we only do either a gable or a hip roof in terms of pitched roofs or a completely flat roof, I would recommend calculating offline an appropriate R value based on that change in thickness and inputting that as a characteristic for say attic insulation or flat roof insulation. And when you do that, you want to not just take the average thickness and an R value associated with that, but because the U value being the inverse of the R value as a function of thickness, what you really want is the correct effective U value. And so average thickness and won't necessarily give you the right answer in terms of an effective U value for the entire area.
Correct, because in the back shallow area, you're going to have a ceiling joist touching the roof rafter, where in the front you'll have a ceiling joist that may or may not be buried in insulation, but a lot of big airspace above it. So some of the areas will have different U values, and it will have to be proportioned. Right.
Now, another thing that you might do here is, I'm thinking out loud, which is a little dangerous on the spot here, but you could think about whether if you did an unfinished attic, so I'm selecting that as my space type, and doing this, and then went and made this a very low pitch, even though your building is pitched entirely in one direction, and if this was 6 inches here, and I believe you said 3 feet at the other end of the building,
I'm getting closer.
I'm trying to, well, be closer, and yeah, it may still be difficult to get the total area right. Okay, so anyway, this is definitely an issue that would require some workarounds in that BOP doesn't have complete flexibility for that sort of pitched, single direction pitched roof.
Can you speak briefly about changing the window characteristics? I understand if you have 20% on each side of the house or 30% on certain sides, whatever. But if I have some windows that are going to be double pane, some are single pane, some are wood, whatever, in retrofit application, creating my existing case, am I going to have to do off spreadsheet U calculations of coming up with the averages of all the different directions and then working through it, much like we just talked about the roof insulation?
So at the moment, if you go to the Windows category on the option input screen, BOP does offer the ability to specify window types on a per facade basis. So you can have different windows on the front, the back, the left, and the right, but only one window type on each of those facades. And that's indicated actually by the last option there, where we say back windows equals high solar heat gain coefficient. So what you could do is you could create your own option and start by copying this option and specify U values and solar heat gain coefficients for the 4 facades of the building.
Okay. I never went down to the bottom of the to get to that particular option.
Yep.
Yeah, that's a useful hint. Perhaps in some categories we put an option in, not because it's necessarily a meaningful option, but to kind of illustrate what you as a user might do in terms of making your own option. Yep. So it's just kind of an example option.
And we also do have some description. There's a lot of description in BOP, so it's easy to miss, but in the category notes here, it talks about options being defined facade specific or single window type for the building.
Okay, thank you very much.
Mr. Wong, you may ask your question.
Yes. Second is for space conditioning equipment, ground soft heat pump system. for the unit 12 and 13. Why for the higher efficient ground source heat pump system is more linear feet per ton? For example, unit 13, the ER and the COP is higher than the unit 12, but the linear ton, why is this? Oh, you guys changed it. Oh, I have a 2.003. So for the new one, you already changed it.
So I'm not sure about the question, but just a comment here is that in the ground source heat pump options, where you can choose standard grout or enhanced grout, a low conductivity soil or high conductivity. So whereas so BOP does a sizing technique so that these enhanced situations reduce the amount of heat exchanger required. So the biggest effect of improved conditions may be in terms of reducing the cost of the installation as opposed to improved performance. And so that's something to bear in mind, that the sizing technique does that and actually kind of sizes to have the right ground exchanger, heat exchanger capacity.
I'll just make one other additional comment, which is in terms of the feet per ton number that you see, you can hover over any one of these columns to get more information on them. And specifically on this heat exchanger Boar one, there can be a point at which, when you're going to a more efficient system, that you cross over from sort of being sized based on heating to being sized based on cooling. And so you don't get a trend that you might expect to get based on the specific EER and COPs of the systems. So it is possible that for a given, and these numbers are climate specific, so I'm not sure what climate we're in, but you can get a trend that is not so obvious, and I think the note at the bottom of this tip tries to talk about that point.
Does BOP account for the heating balance on the ground loop? For example, in the cooling dominated building, the cooling load, heat rejection is much higher than the heat extraction.
Yes, that is accounted for.
And what's the borehole configuration on this option?
Let's see. Where this is. Go ahead.
If you right-click on the headings there, you can see that you can show additional columns. You can choose to show the column for bore configuration. So you can actually choose different bore configurations. And all of these default options are, the bore configuration is auto-sized.
Okay.
And that's a rectangular configuration.
I see.
Depending on size, either linear or rectangular.
Thank you.
You're welcome.
Alexander Lovallo, you may ask your question.
Hello, just a quick question about installing BOP. Is it a standalone installation file, or do I need to have the engines installed in the background? And if I can't get it to run, are you guys familiar with typical causes?
You trailed off a little bit on the end there. I'll talk about your first question first, which is you do need to install both the BOP setup file and at least one of the two simulation engines that BOP links to, either DO2 or Energy Plus. Let's see, if I go to the BOP website here, On the download page, let me log in first. On the download page for BOP, at the bottom, so you can download the BOP setup file, and then you need either the Energy Plus or the DO2 setup as well. And there's links right there on the website to it.
Okay, and when I open BOP, I get the first screen where I can select, the California or the other options, and then a new building or retrofit. And no matter what I select there, when I hit OK, it just sits forever.
Why don't you, maybe through the website, there's a Contact Us button. If you could email us, we can try to figure out what's going on in your machine.
Okay, thank you.
That's certainly not the intended behavior.
I appreciate it.
Brian, you may ask your question.
Yes, hello. I'm curious to know if you can define occupancy in BOPs and how perhaps you can also set a schedule.
We do have some availability for doing that. So now I guess the question is when you say occupancy, so there are occupant-related schedules for thermostats, heating and cooling thermostats, miscellaneous electric loads, miscellaneous gas loads, and natural ventilation operation and interior shading. So I'm going to let Eric talk about the details, but actually we don't have a schedule for occupants per se that would dictate these other schedules. That's something that we thought about doing, but right now we have the individual schedules and not an overall occupancy schedule.
And so things like the number of occupants themselves and the hot water usage are set by the number of bedrooms, and which is specified on the geometry screen just above where the rendering pane is. So we have an equation that defines the assumed number of occupants for a given number of bedrooms. And you can find details about all of these assumptions about number of occupants by going to the Help menu. And if you select the Building America House Simulation Protocols, that document contains all the assumptions about occupancy and operating conditions that are built into BOP. Does that answer your question?
Yes, I believe so. I had one other question. I was just curious to know if there's a way you can define wall assemblies separately for the separate walls.
So currently you can't define separate wall assemblies. You have to use the same construction and R value for all walls. There is a workaround if your building doesn't have a garage, then you can draw a garage next to the wall that is different, and then the interzonal wall category will show up on the options screen, and you can use that category to define a separate wall type for those walls that defines the wall type between the garage and the living space. So that would be the workaround for that situation.
So that workaround would allow you to define two different wall constructions, one where the garage, between the garage and the house, and the other where between the house and the environment. The other suggestion I would make is that there is a wall category called Other that is a more general category where you can put in properties of walls, and it might be worth, you could do an offline calculation to come up, similar to the question, let's see, what was it, related to the roof previously. If you did an offline calculation to come up with a area weighted U value and created your own wall option in the other category, that might be your other way to do that.
Sense. Thank you. I was curious to know, it seems like this is mostly geared toward residential. I don't know if there are more commercial related options.
You're correct. This software is aimed specifically at residential. We have been recently enhancing it somewhat to do various types of single-family attached buildings where there's multiple units adjacent to each other and both horizontally and vertically. But yeah, it's funded by the U.S. Department of Energy residential program. We have a group at NREL geared towards commercial building modeling using Energy Plus and a software platform called Open Studio. And so there's various options available via Open Studio for non-residential buildings.
You said Energy Plus and Open Studio?
I'm sorry, say again?
You said Energy Plus and Open Studio?
That's correct. Energy Plus is the simulation engine. Open Studio is a modeling platform that connects to Energy Plus but has a number of other features as well.
All right, great. Thank you.
You are welcome.
George Weiss, you may ask your question.
Great, thank you. I was trying to see if there's a way to model a economizer basically in this, and it looks like if on your HVAC areas, it's probably not an option. Would there be a way to do that under the whole house fan kind of option, or anything else you could think of along that line?
Well, we currently don't have a whole house fan option. That's something that we've been working on adding. I might recommend using a natural ventilation option.
Okay.
And if you select one, you could select properties, and you could probably configure it to kind of operate like an economizer, so that it's always available. You know, I imagine you're talking about something with a sensor where it would, bring air in when the temperature outside is below a certain point. So,
Correct.
So this wouldn't be able to account for the fan energy associated with that. You could maybe do that calculation offline, but this might be able to give you an approximate way to do an economizer. And you can look at the D view at the hourly output to see when natural ventilation is being utilized.
I'll just mention also, I don't know how familiar some of our users are with the underlying simulation engines themselves, but if any users are familiar with the underlying simulation engines, it is very easy to get the input file that BOPT has created to run those simulations out of BOPT, and then you have full flexibility to be able to modify those input files themselves if it's just, let's say, a single building that you're trying to get energy results for. So you could take a building modeled in BOPT, generate the Energy Plus or Go-To input file for it, and then make the necessary modification in that simulation engine language to put in a technology. But if you're not familiar with those simulation engines, then you're probably not going to want to take on that effort.
And I did want to reiterate what Eric said about this would be a classic case, among others, that if you are doing the inputs for ventilation, cooling, for example, anything with controls, it's definitely a good idea to open hourly results in DView and inspect what's happening to see if the building is performing as you intended. And that's not a bad idea just in general to look at hourly results.
David Beal, you may ask your question.
Hello, guys. I've talked to you about this before, but could you go over the way you model duct leakage a little bit?
That's a kind of general question there. Could you maybe be a little more specific about?
Well, my specific problem is that I think what you're looking for are nothing that I have ever measured. So we use duct blasters and we get a number at a specific pressure. But you guys, you know, what does the 15% leakage mean? I understand what R6 means, and I understand location in a unfinished attic. I know I can fix where you have put everything. You know, what the Building America modeling protocol does not represent what we do in Florida in the least. You stick air handlers up in the attic, which fails code down here.
So, so the total leakage, that fraction, that number represents the fraction of the supply air flow rate that the fan sees that
lost
leaks out
to the outside, or
pardon
lost, period.
Well, if you look at the detailed simulation variables here, we have we separate it out by supply and return leakage, and we also separate it out by duct leakage and air handler leakage.
But it's total leakage. You don't really care where it goes.
Well, we actually, well, depending on where your ducts might be in a different location than your air handler, so that's why we account for those separately.
Right.
But so to get this number from a duct blaster number, you could look at the ASHRAE Handbook of Fundamentals, and there's some equations having to do with different leakage classes that where you can take a measurement done at one pressure, and
if we knew the operating pressure, we might be able to go from there.
And that can help you get a leakage flow rate, but you could then divide by the fan flow rate to get this leakage fraction.
But I would be, so last guy I talked to wasn't real familiar with the duct blaster procedures, but we typically measure two things: the total leakage, which just uses duct blaster on the duct system, and then leakage to the outside, where we pressurize the house and the duct system to the same pressure. And obviously that's the important leakage. So I think basically what I'm saying is there's some leakage around the registers, the grills, which is irrelevant, but that is part of your 15% leakage, isn't it?
Well, I think these numbers would be considered leakage to outside.
Would be considered leakage to outside.
Yes.
So if we find the shoe size factor there going from 25 pascals to 57 or whatever it's operating at, then take our leakage to outside number and convert that into a percentage and make, define it in the, I see you're in the options manager, so just define it in the options manager.
Yeah, David, I think, why don't we maybe take this offline, because I think it's going to get a little bit detailed for the audience that we have.
Yeah,
but I guess the general
so much of the audience probably doesn't have, I think most of the audience does duct leakage testing the way I do.
I don't disagree with that. So the comment I was going to make is the duct options that we have in BOPS are a little bit characterized in the way they are because those are partly how the simulation engines describe.
Right, yeah.
So we're trying to, talk to those engines in the way that they understand. That being said, in our upcoming version of BOPS, we have very useful here to be able to describe options in different ways, and I think we at NREL should consider trying to add, because that's not the only way you can describe ducts too. TFM per ton, people talk about all sorts of different ways describing ducts, and so I think we can take it on ourselves to try to expand the way that you can describe duct options in BOPS, and I think that would be useful to all of our users, and certainly having duct blaster inputs would be one of those capabilities. But I think specifically to using BOPS, in the short term, I would suggest sending us an email, and we can follow up on that in more detail if you like.
I think I need to spend a little time looking at the, man, I keep on trying to open your options manager. It's driving me crazy. I'm sitting here looking at the screen, and it's like, I can't click new. Thank you for your time, and I guess that's probably a pretty good answer. So,
thank you.
Okay.
Austin Selvig, you may ask your question. Austin, your line is open.
Oh, sorry, I forgot the mute button there. I just had a question about the basement. You said before that you can specify insulation if it's a slab. Can you specify insulation underneath the basement or a garage slab?
So let's see. To answer the second question first, under the let's see. Let me close out of here. There is not an option to specify insulation under the garage slab. The garage being unconditioned, we thought that would be an infrequent option. And let's see, I'm going to look here, refresh my memory a bit on, if I go back, got my funny looking building here, and make this a basement. So let's see, foundation, finished basement. The built-in options here, now this is a finished basement, so there are some inside insulation options. I'm trying to remember where we stand on this from Dena. The individual that has worked on this most recently is not with us in the room. And I know we've added the ability to do entire under slab insulation beyond the perimeter at varying R values. And it may be that I'm going to have to ask you to send us an email and we can get back to you on this.
Okay.
I'm sorry, I don't know right off the top of my head.
Okay. Yeah, I just saw that, and I'm working on something that's supposed to be closer to kind of passive house, so definitely lab insulation and.
Yeah, and passive house, had motivated us to do more aggressive under slab insulation, but I don't think we have under the basement floor insulation option. That surface is quite a ways from the ground to air interface. But in passive house design, often the insulation options are pretty aggressive.
Mm-hmm. Okay, well, I'll send you that email then.
Okay, thank you.
Thanks.
Lee Dodge, you may ask your question.
Thanks. People that sell insulated concrete form houses talk about a thermal effect or a thermal inertia effect of the mass of the walls. And I have used BOPT and looked at that and not seen much of an effect. And I just wanted to be assured that in order to get that right, it would need to be doing hour-by-hour calculations. But does BOPT always do hour-by-hour, whether you're using DOE or Energy Plus or all those options?
Yes. Yes, it does. And as indicated, in the fact that with the DView visualization, you can in fact look at hour-by-hour results. So are you speaking of above grade ICF walls?
Yes.
Yeah. So as you can see in the simple option descriptions here, there is foam insulation. represented somewhat simply relative to the specific geometry of some ICF products, that have cellular kind of 2D, 3D geometry. But there is definitely the inclusion of here 4, 8, or 12 inches of concrete between 2 inches of foam on the inside and the outside. So that the concrete is there and does have a thermal mass effect in the hour-by-hour calculations in each of the simulation engines.
Okay. Well, you've answered my question. And if you all, when I do it, I see almost lost in the noise any savings for that thermal mass effect, even looking in areas where I think where there's large diurnal changes of temperature. Have you guys looked at that or have any thoughts on that?
The thought I would have on that is that if you were in a situation where you had a kind of significant deadband between, or range between the heating set point and the cooling set point, and your diurnal outdoor temperature fluctuations were such that you were not purely in heating mode or cooling mode, that would be the circumstance under which you would expect to see the most effect. If that makes sense. If, the thermal lag of the concrete or the thermal mass in the ICF would not be expected to have much effect on energy, unless you're kind of swinging in and out of the deadband. In other words, if you're in a purely hot situation or purely cold situation, there's a lag in terms of the heat conduction through the wall, but it doesn't necessarily affect the energy.
I agree with your comments, and I appreciate you guys giving us this software tool to work with. I found it very helpful. Thanks.
Glad to hear that. Again, this would be a case where I would look at hourly results in DView with regard to the question that you're asking.
Good suggestion. Thanks.
Sure.
At this time, I show that we have no further